Welcome to the Inside Java podcast, a podcast about everything Java brought to you by the team at Oracle that builds Java. My name is David Elbasset and I'm your host today. I recorded this episode during Java 1 with Tomas Langer. Tomas is the Helidon architect here at Oracle, so this episode discusses Helidon Níma. Tomas is sharing his views on Project Loom, but more from a library, more from a framework developer point of view. He goes on why and how Helidon Níma started to adopt virtual threads, the benefits virtual threads brings, but he also discusses some of the challenges he had to face. Enjoy! So, Tomas, you did during the technical keynote a cool demo with Helidon Níma and virtual threads, so I thought it would be nice to have a conversation on that. So before we dive into that, can you give to our listeners a quick overview on Helidon?
Of course. Helidon is a set of libraries for developing microservices, and we provide libraries to build microservices either in a reactive environment where you basically write what you want to get. There is no magic behind it, and it's really fast. They designed for high concurrency. We also provide Helidon microprofile approach where you use inversion of control, injection based on CDI, JAX-RS, and the microprofile specification.
So right now the current version of Helidon is 3, right?
Yes, that's right. It's 3.0.
Can we quickly go back over the history of Helidon?
Of course. We have started writing Helidon somewhere around the year 2016 and open sourced our first 0.x version in 2018. That was running on Java 8, and we already had Microprofile 3 supported. Then in 2019, we released Helidon 1.x and started having production customers. And those versions are currently no longer supported. So what is supported is Helidon 2 and Helidon 3. So Helidon 2 was released in year 2020, and its minimal Java version is 11. And then Helidon 3 was released just a couple of weeks ago, and that's running on Java 17 and Microprofile 5.
Okay, cool. So the current version is Helidon 3, but today we're going to discuss Helidon 4, right?
That's right.
Okay, so let's zoom on Helidon Níma, which is the project name of Helidon 4.
Helidon Níma is a new approach that is using imperative blocking APIs to write your services. So we still have Helidon Reactive, we have Helidon Microprofile, and then we have the new Helidon Níma, which allows you to write as fast services as with Reactive, but using virtual threads.
Okay. So that means that you are using Java 19 and preview features.
Of course, yeah, we needed to switch to Java 19 and its preview feature, Project Loom and its virtual threads.
Yeah. Can you explain in a nutshell what is the architecture of Helidon Níma?
All right, so the core of Helidon Níma is the web server, which provides by default HTTP 1.1 support, and we have modules that extend that support to HTTP2, gRPC, and WebSocket. And on top of that, you can add libraries for things like observability and the usual features that we have in Helidon, metrics, tracing, and all the others.
Okay. In terms of features, so you mentioned tracing.
Yeah, there's like the first focus we have is on observability. So you have health check support for Kubernetes probes, so you can plug it easily into your Kubernetes environment. There are metrics, which the most common use case is that you scrape the metrics using Prometheus, for example, and then display them through Grafana. And there is tracing, which provides an end-to-end trace of the service flow. So if you have multiple services executed within a single request, you will actually see it in a nice graphical view. And we support currently basically all open tracing and open telemetry tracers with a better support for Zipkin and Jaeger that is built in.
Okay. Now, obviously, the big thing in Níma is that it's based on virtual threads. So can we discuss a little bit about the threading model that you are using?
Of course. So virtual threads are in general great when you have a request that needs to block. The virtual thread will not consume the platform thread for the duration of the blocking. So we utilize that in our server-side by using a virtual thread to handle connections. So what needs to happen when you start a server? You start your server sockets and you listen on them. And for that, we still use the old platform thread because the server socket is open for a long time, and there is a very few number of them. You will have probably 2, 3 when you start a web service or a microservice. On top of that, when a request comes to create a new connection, we start a virtual thread. And this virtual thread is running for the duration of the connection. And it doesn't matter if it's HTTP1 or HTTP2. In both cases, it works the same. Also, if you want to have like boost in performance for some highly concurrent requests, you can have an additional virtual thread to write bytes to the socket. So basically there is one to read from the request and carry out routing and one for writing the responses. And then in HTTP2, there is an additional virtual thread created for each request that comes to the server. So in HTTP2 terms, each stream on HTTP2 has its own virtual thread.
And if I recall correctly, so over HTTP2 you can have multiple streams over one single connection.
Yes. So how it works is that in HTTP2 you establish a connection, and then you have parallel streams that are using the same connection, and you basically write data and you notify which stream this data belongs to, and the server deconstructs it and sends it to the correct handler of that stream.
And you said that for each stream you have a virtual thread.
That's correct.
Okay. So that means that in HTTP2 you pay the price of the connection at the beginning and that's it.
Well, it's the same with HTTP1 and HTTP2. The difference is that in HTTP1, the one connection can only serve requests sequentially. So you get a request, you return a response. You may use pipelining, but not many people use it, but it's still not parallel. It's still like you send 5 requests and then you need to get 5 responses in the same order. With HTTP2, you create a connection and then you can just run requests on it and return responses. So it really maximizes the amount of data that you can send through a single connection when some of the requests are waiting, for example, for data from a third-party service or from a database.
Okay. Can we now discuss a little bit about the benefits of virtual threads?
So I think that I can easily demonstrate it on the HTTP2 implementation because if we didn't have virtual threads and I implemented the HTTP2 server the same way using platform threads, then basically I would have a platform thread for each connection and then another thread created for each request. And now imagine that the modern servers under load can serve, like 10,000 parallel requests.
Mm-hmm. So
that would mean we would have 10,000 parallel platform threads. Like JVM cannot handle that. In most cases, you can survive, like 400 threads, maybe 1,000 if you have a really strong machine, because then you have a lot of overhead on, the thread stack size, and there are just things that need to happen, and also on context switching that the CPU is then spending its time on.
Yep.
So it's just impossible to implement it using platform threads. And virtual threads give you this option to use them, and basically the thread is only pinned on a platform thread when it executes something runnable.
Mm-hmm.
And as soon as it reaches a blocking operation, such as I need to call another service over HTTP or I need to talk to the database, and when you start this invocation and Java knows, we are reading from an input stream, but there is no data available, so it will park your virtual thread and use the underlying platform thread to run something else. So it basically works like a non-blocking server, but from the point of view of your programming, it's blocking.
Okay, cool. Have you done some performance measurement already?
Of course. So I will probably start a bit with the history, how we started with Nima. And when virtual threads were introduced into Java as a totally separate installation of JDK as a preview feature, I thought that this looks like a great thing. Like this is the new thing in Java, the best thing in Java since Java 2. And I decided that I want to write a prototype of a web server to see if we can reach the performance that we have, for example, with Netty in Helidon, because Helidon is currently based on Netty server.
Yeah, you mean current Helidon. So
Current Helidon, yes, the reactive implementation. And I was thinking, like, if I can reach similar performance using virtual threads on top of a what I call naive implementation of a web server using virtual threads,
naive,
as we get with Netty, then it's worth the work, and we should continue with that. And we managed to create this proof of concept, and we actually reached like 95% performance on the highest throughput benchmarks.
Okay.
And we were faster in the benchmarks that use, for example, JSON to just a GET request to return JSON, and that was basically the yes to continue implementing.
So what you are saying is that proof of concept, that prototype that you've done using the early access build of Loom the performance benefit that you got was the trigger to start really to work on what Nima is today.
Yes, that's right. We just decided, yes, this makes sense, and we invested more resources to really continue with the implementation.
Okay, so performance was the first trigger, and then because one of the benefits of using virtual thread is that the programming model is also a lot simpler.
So actually, the original trigger why we even started with the proof of concept was that I knew that if you use virtual threads, you go with the imperative programming model where you can just block as much as you want. And for all the people who ever tried reactive is incredibly hard. You need to have a very good implementation of the reactive stream operators, but you also need to understand deeply what is happening, because a small error and your service will not return anything, and you will not know what happened, because if you do a thread dump, there is no thread. It's non-blocking. There is no thread blocked anywhere. And opposed to that, programming on virtual threads gives you, an absolutely straightforward program where you can see what's happening. When you debug, you will actually see where your code is at and what, how you go through it. And if you have an exception, you can see it immediately. The stack trace will be meaningful.
Yeah.
And if you do a thread dump, you will see that my thread is blocked on this place in the code. For example, it's waiting on a web client request where we forgot to add a timeout.
Yep.
And you can immediately fix it. With reactive, like, you lose a lot of these features. So we knew that this is the advantage that we could get, and the only problem I was afraid of was that we will not be as fast.
Okay, yeah.
So we created a proof of concept. We found out we can be as fast. So we said, okay, then there is, this makes like 100% sense.
Yeah, it's a win-win. There's no reason to not do it. Okay, cool. Now, is everything pink, or did you have to face some challenges, or because until now everything looks great?
Yes, well, there are challenges, and a few of them are common for reactive and virtual threads. So let me go through it a bit. So first one is this quite commonly mentioned is obstruction of a thread.
Yeah.
Obstruction of a thread is the case where you write code that fully utilizes a CPU, and you need to go deep into the API and start using things like thread.yield to make sure that others also can execute something on your CPU. And this problem is actually in both worlds. So if you have a thread that needs to do this kind of obstructing work, both in reactive and with virtual threads, you need to run it on a different thread, do all your work like yields and so on, and then return back the result. In Nima, the result will be returned by just blocking on a future. So I get a future and I say future.get, and then I sit there on the virtual thread, and when that asynchronous thread finishes, I just continue with my request. If you are in reactive, you will probably have some kind of completable future, and again, you do then apply, and then you send your response. So very similar solution, only in Nima you just block and wait.
Okay.
So there are things that I had to encounter when I was coding Nima, and that's very interesting because in most cases we are so much used that asynchronous and non-blocking is better, that you basically have to unlearn stuff. You need to force your brain to stop using it. And I started the first implementation was actually based on non-blocking server socket channel. And that actually the performance wasn't very good. And then we changed it and we just use, server socket, and we use input stream and output stream, and it's all blocking. And suddenly the performance went up. And you realize that there's quite a high cost when you need to go from one of these approaches to the other. So whenever you need to switch between non-blocking and blocking, you pay a cost. And basically in Nima, I had to learn that never ever do that. You need to do something, just block. Wait for it. It will work better than trying to work around it.
So the problem is that you need to switch your brain to blocking is good.
Exactly, and that was quite a hard thing, and we are still struggling with it because every time a team member, goes and works on Nima, I need to,
you can block.
You can block. It's fine. It will work, and we are getting there. And the great thing about it is that it's actually much easier. Like the code is cleaner. For example, in the integration layer with the web server that we have for microprofile, we have removed like 90% of the code that we had because we had a Netty. On top of that, we had reactive implementation of web server for Helidon because Netty on its own is non-blocking, but it's not a reactive stream thing. So you need to go from Netty approach to reactive streams. And then with our microprofile, we had then to go to blocking approach because we are running a JAX-RS implementation, Jersey, which again expects an input stream and an output stream. So there was like this two ways of, transforming your requests. And with Nima, I already have an input stream and output stream. So I just give it here, Jersey, please, continue working. And that actually improved the performance by 100%, just that you remove, all that code from there. So there are some real benefits. So back to some of the challenges that we have faced. One of them is related to features of Helidon. Because sometimes you have features like metrics, which are not really related to whether you are reactive or blocking. The metric just cares if you increase a counter or you say here start and here finish and measure the time in between.
Yep.
So these are the features that we can easily reuse between all of the Helidon flavors, and it works. There are also features where we have to make the decision to write them from scratch. And a very good example of that is fault tolerance, because our implementation of fault tolerance is based on reactive streams. And of course, you don't want to reuse that in a blocking environment.
Yep.
So the blocking fault tolerance is written from scratch to support virtual threads and to do the best thing for that environment.
Mm-hmm. Something I heard, synchronization might be a challenge, no?
Yeah, okay, so let's get now to where there are still some open questions on virtual threads themselves within the JVM.
Okay.
And that would be two things that I'm aware of right now where we need to be careful or we need to understand what's happening. So the first one is synchronized. So if you use the synchronized keyword in the current version of Java, which is Java 19, it is actually locking the thread that you use, the platform thread, and you stay pinned on that platform thread. So basically, if you have a synchronized block, then you will be using that thread. In general, in your code, this is not such a huge problem because you can switch to Java util concurrent locking and it will work fine. Mm-hmm. But when you use, for example, third-party libraries and most significantly JDBC drivers, most of them use synchronized. So you will have some trouble with the virtual threads there. Luckily for us, new versions of these JDBC drivers are being created or are already out that switched from synchronized to locking. So they will work fine with virtual threads, but definitely there will be a certain period of time when we will need to wait for the industry to catch up and prepare better solutions. But I think that this can be fixed very easily. Honestly, it's really just about the libraries. One thing that will probably take slightly longer time is file system access.
Yeah.
because right now the file system, when you call it, is it is blocking on the operating system level. So the C APIs that you use are blocking, which means that Java just doesn't have a really good tool to write it as a non-blocking and correctly handle virtual threads. A side note, this is also true for reactive. So if in reactive code you try to access the file system, you are blocking it as well. So you basically shouldn't do it either. The solution for that is being worked on. Of course, Java team is aware, and luckily for us, in the latest kernels of Linux, there is the IOURing approach, which supports also asynchronous non-blocking approach to file system. So eventually we should see this in Java itself. Otherwise, you have to be careful. If you do too many file system operations, you should probably delegate them to a separate pool. Or actually right now what happens in Java is that the JDK itself will increase the number of executors in your forkgen pool when it knows that you are using file system.
Okay, so that's the JVM that...
Yeah, JVM is understanding it. It knows you are on a virtual thread. And because you are accessing file system on a virtual thread, it will replace basically that thread with a new one, so your system still works.
Okay, cool. Sweet. I think we had a good conversation, so we should probably start to wrap up and talk a little bit about what's coming next. So one of the questions I have, so if we look at the Java 19, there's a virtual thread, preview features, but we also have from Project Loom a structured concurrency, which is an incubator module. So have you looked at structured concurrency yet?
Yes, we did look at it, and it has one huge advantage, structured concurrency, that if you do a thread dump, you have hierarchical thread dump. So, and we tried this. What we could achieve is that basically each thread that you use has in its name the identification of the socket. So, for example, if you have multiple streams on an HTTP2 request, HTTP2 connection, the HTTP2 connection has the socket identification, and then each of the streams has its own identification as well that we print to, for example, logging.
Yeah.
And then if you do a thread dump, you would actually see this connection has these virtual threads running on it, and each virtual thread is named by the stream that we have assigned to it that you can also see in logging.
You mean the HTTP stream?
Yeah, HTTP stream, sorry. So if you do the thread dump, you can actually map it to your log output, and it's also hierarchical, so you can easily see in the thread dump that these 5 threads belong to this HTTP connection. So it's great. We did not implement it yet, first because we wanted to use just the preview features, which is, it's like a level up from the incubator.
It's stable, might still evolve, but it's stable.
And second is, as you said, like the stability, because when I first used it, it looked cool, but then, the API changed like heavily, and we basically needed to remove it because I didn't want to spend so much time on it. It's easy to add.
Yep.
And as soon as there is a preview feature of structured concurrency, it will definitely be added at least to HTTP2, where it makes a lot of sense.
Yeah, that mapping between the HTTP stream, that's very sweet.
Exactly. And, maybe we will add it also to others. So you can, for example, see which threads belong to a specific open port.
Mm-hmm.
So there will be like the server socket would have its own thread, and the structured concurrency, the child threads would be all the connections that belong to that server socket. So definitely that's one thing that we will use as soon as it is available.
Now, what about Helidon? I mean Helidon itself in terms of new capabilities, Helidon 3.
So Helidon 3 is a brand new version. We have released it really last month. So the biggest change that we had there in microprofile, we switched to Jakarta packages. And that's it's a huge backward incompatible change, but on the other hand, it brings us to the latest Jakarta EE specs and also to the latest microprofile specification. So that's like modernization going forward. Second thing that we changed was that in Nima, we used a specific approach to routing, and routing is the place where you define your endpoints for your HTTP. So things like I want to have a get request on /greet that will invoke this method. So that's routing API. And we just wanted to align it that when you use 3, it will be very simple for you to switch over to Nima because that uses very similar approach. So those were the two biggest features in Helidon 3.0. Now for Helidon Nima, we have right now Alpha 2 release, where we introduced a few of the features that we have also in Helidon SE and MP. And we also introduced one, it's a small thing, but really useful. You can actually have checked exceptions on your method that executes the route. So you can, for example, use file system operations, and you don't need to do a try-catch block, except for closing, of course, your output stream if you use it. But in general, if there is a checked exception, you can just let it bubble to the Nima web server, and of course you will get a 500 back. But you can do it. There is like no, it makes it much easier to do, like, even for demo, if you want to do thread.sleep, you don't need to catch that, interrupted exception. You can just leave it there. So that was like a small thing that helped a lot with demoing and writing stuff. For the future, for Alpha 3, we already have merged a PR that introduces Helidon microprofile on top of Nima, which was quite a major change because all of the features that we integrate are integrated currently with the reactive web server, and we needed to switch to integrate with Helidon Nima, but that work is mostly done. We can actually run Helidon microprofile that is using the Nima web server. And as I said before, that introduced some, significant increase in performances, and also it introduced much smaller API on the integration level. So helped us a lot.
And that's for the next release, of Nima, so the next one.
Yeah, that will be Alpha 3. And as soon as we return from Java 1, we will start working heavily on basically productizing and making it production quality in Nima. We already have requests for customers who are willing to use preview features, because they understand the benefit of virtual threads. So we want to give them something that they can use in production. So that will be the next big task for our team, to deliver at least a subset of the features in production quality.
Okay, that's sweet. Now, what would be your call to action to people listening to this podcast?
So I would definitely recommend to go to helidon.io/Nima, where you can find a link to our information about Nima. And one of the links is a blog article which introduces Nima and also introduces an example which is available on GitHub, where we have a reactive implementation and a Helidon Nima implementation of exactly the same service. So you can, if you clone this example, you can go and see how it works, play around with it, and definitely we are interested in feedback. So we are on GitHub. It's github.io/helidon-io/helidon. We do everything in public. So we are an open source project, and issue tracking and project management is actually done on the GitHub repository.
And what is the best place to provide feedback?
Definitely issue trackers on GitHub. And if you go to helidon.io, you can also find our Slack channel if you want to just chat a bit. And of course, we are also following a Stack Overflow. So even if you ask there, we will answer and help you with whatever Helidon related.
Okay, great. Well, Tomas, thank you. I wouldn't try to say thank you in Czech, but thanks for your time. It was great to have you.
Thank you very much for inviting me.
And congratulations for what you are doing with Nima.
Yeah, we really love that.
Thank you. Bye.